This is Algebra 2, Unit 6, Lesson 4, and this is on the quadratic formula. In this unit, we've been learning all the different ways to find the roots of quadratic equations. And we've learned so far that you can do it by factoring, you can do that by the square root method, or completing the square. The fourth method is the quadratic formula. And the good thing about the quadratic formula is it will work for every single equation I give you. Completing the square will always work, but sometimes those numbers get so complicated you don't want to have to use that method. But quadratic formula will work no matter what you have, as long as it's a quadratic equation. And the quadratic equation standard form is f of x or y equals ax squared plus bx plus c. A, b, and c are going to be integers here. So it's basically just a formula that we plug into. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So for my first example here, I've got x squared minus 12x equals 28. So like I said before, I'm going to move the 28 over. So I've got x squared minus 12x minus 28 equals 0. Then I have to identify the a, b, and c in that equation. My a is the coefficient of the x squared term, so it's 1. B is the coefficient of the x term, that's negative 12. And c is the constant, negative 28. Then I'm going to take those numbers and I'm going to plug them into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I plug in, negative b means the opposite of b. B is negative 12, so the opposite of negative 12 is 12. Plus or minus the square root, well, b squared, negative 12 squared is 144. Minus 4 times a, which is 1, times c, which is negative 28, all over 2 times 1, which is 2. Then I just solved this using order of operations. So x equals 12 plus or minus the square root, well, 144 plus negative 4 times 1 times negative 28 is a positive 112. That's still over 2. So then we have x equals 12 plus or minus the square root of 144 plus 112 is 256. Still over 2. So then we have x equals 12 plus or minus the square root of 256 is 16 over 2. So when you get here, you do not want to leave it like this. You've got two answers here. If you notice, you can separate this into two different math problems. We've got x equals 12 plus 16 divided by 2 and x equals 12 minus 16 divided by 2. So 12 plus 16 is 28. 28 divided by 2 is 14. 12 minus 16 is negative 4. Negative 4 divided by 2 is negative 2. So our two roots, the two places where it crosses the x-axis, are at 14 and at negative 2. Now, when this happens and you have integer answers in your problem, then what that means is this was a factorable problem. This one could have been factored at the beginning if you look. And if they don't specify that you have to use the quadratic formula, factoring would probably be easier for this. You don't have quite as many steps. Factors of 28 that subtract to give you 12 would be 14 and 2. So when you solve it, you would end up with the 14 and the negative 2. So you could factor this one to get it, but it's good to see what happens here. Now, this is called the discriminant, the number that we get underneath the square root, and that discriminant becomes significant, and we'll talk about that in the next section, but that number right there becomes very important when we're talking about the type of roots, because you're going to have to identify what type of roots you have. And here I have two real rational roots. Here I have 4 more problems, and I'm not going to show quite as much work in these. Really, you should have had this in Algebra 1, so this should be review. So I'm going to go a little bit quicker with the next one. We know that this is a quadratic equation. It is set equal to 0 already, so I don't have to worry about doing that. And if I look at that, I know my a is 1, b is negative 34, and c is 289. So I'm going to go ahead and put that in the quadratic formula. So negative b, I have x equals negative b, well, the opposite of b is going to be 34, plus or minus the square root of b squared, and b squared here is 1,156, and use a calculator for these, there's no reason not to, minus 4 times A was 1, times C is 289, and that's all over 2A, which is 2. And then I'm just going to do the math inside here. When I multiply negative 4 times 1 times 289, I end up with negative 1,156. So we end up with 1,156 minus 1,156. So that gives me a square root of 0 underneath the radical. Well, when that happens, notice this plus minus is just plus minus 0. So if you look at that, really this one only has one answer. Now, we learned when we have a quadratic equation and the exponent is a 2 that we have to have 2 roots. Well, technically here we do have 2 roots. They just happen to be the same thing. And this is what we call a double root. And to describe the roots here, we have one real rational root. When we have this, what that means is the quadratic equation, the graph of that, the maximum or the minimum will be on the x-axis. So it's called a double root when that happens, and we'll talk more about that as we're analyzing these graphs later. In the next one, notice the negative 2 is over here, so we need to move it. We need this to be equal to 0. So we've got 7x squared plus 3x plus 2 equals 0. And if I plug that into the quadratic form, negative b is negative 3. Plus or minus the square root of b squared is 9, minus 4 times a is 7, and c is 2, all over 2a, which would be 14 in this case. Then we're going to do that, negative 3 plus or minus, we've got 9 minus 4 times 7 is 28, times 2 is 56. So we have the square root of 9 minus 56 all over 14. That is equal to negative 3 plus or minus the square root of negative 47 all over 14. Now, that negative 47, we can bring the I out. That's an imaginary number. So this is going to have 2 complex roots. So we have a negative 3 plus or minus I. The square root of 47 can't be broken down any, so we just have to leave it like that. And then that's over 14. We would simplify this if it simplifies any, but for this one, that's really all we can do. So if you look at that, the answer is negative 3 plus I squared of 47 over 14, and negative 3 minus I squared of 47 over 14. We can leave it like this. There is no need to separate that into 2 different answers. That plus minus should be understood to represent 2 separate answers, the 2 roots of this quadratic equation. Now, this one looks a little bit different. The way we do this is exactly the same. The only difference is it's set equal to an f of x instead of 0. We just need to understand that that would be set equal to 0. And our a is 2, our b is 4, our c is negative 5, and then we plug into the quadratic formula. So x equals negative b would be negative 4, plus or minus the square root of b squared is 16, minus 4 times a is 2, times c is negative 5, all over 2a, which is 4. And then we simplify that. We've got negative 4 plus or minus the square root of 16. 4 times 2 is 8, times negative 5 is negative 40. So we've got minus negative 40, which is plus 40, all over 4. And we have x equals negative 4 plus or minus the square root of 56 all over 4. Now let's think about that. 56 can be broken down into a 2 and a 28. 28 is a 4 and a 7, and 4 is 2 and 2. So we can bring a 2 out of that. So we've got negative 4 plus or minus 2, square root of 14 is left inside, all over 4. And then notice that the 4 and the negative 4 and the 2 are all divisible by 2. So we can divide those all by 2 to end up with negative 2 plus or minus the square root of 14 all over 2. And that would be the simplest form. Again, we have 2 real irrational roots there. For the next one, notice instead of being equal to f of x, it's equal to y. We do this one exactly the same thing. We're going to pretend like it's equal to 0, and we're going to plug in. So for this one, my a is 1, b is 6, c is 10. So if I have it, I have x equals negative b, or negative 6, plus or minus the square root of b squared is 36, minus 4 times a is 1, times c is 10, all over 2 times 1 is 2. So x equals negative 6 plus or minus the square root of 36 minus 40 all over 2. So I have x equals negative 6 plus or minus the square root of negative 4 all over 2. And then that can be simplified to negative 6 plus or minus negative 4 has a negative under the radical, so we can take out the I, and 4 is a square number, so we can bring out a 2i. So we've got negative 6 plus or minus 2i all over 2, and that can be simplified. 2 goes into all of those, so that is negative 3 plus or minus I. Again, we do have 2 roots there, negative 3 plus I, negative 3 minus I. It's okay to leave it, negative 3 plus or minus I. In that one, we have 2 complex roots. So there are several different types of roots we have. We could have 2 real rational roots. We could have 2 real irrational roots. We could have 2 complex roots, or we could have 1 real double root. When it's a 1 real double root, you understand that the 2 roots are the same number twice. And we're going to talk about in the next section how that relates to graphs.